see single linked list, so you all know that you all know array, right? It is a collection of elements in contiguous memory location. So if you take an integer array, right, like this, you want to store 10 numbers, 10 different integers, right? 55, 65, 22, like this, you want to store 10 integers, right? So you declare here and you can store 10 integers, right? So if this is 1000, right, if this address is 1000, what would be this address? 1000? 1004 integer array, right? So each element occupies 4 bytes. So the next element will be stored in 1004. So this A, right? If you print A, gives the base address of your array, right? Which is 1000, right? So when I do A of 0, right? What the compiler does? It increments. Suppose I do A of 1. It increments A by 1. So if you increment A, right? A is an integer pointer. So if you increment, what will be the A initial is 1000. A plus 1 will be 1000. 1004. Always when you do increment of a pointer arithmetic you have to remember. Integer pointer of increment by 1. If increment, it will be increment by 4 bytes. Always when increment a pointer, see what is the type of the pointer and what is the memory occupied for the data type. It will be incremented by that many bytes. If it is a character array, it will be incremented by 1 byte only. Okay. So it will increment and then this will be 400 and then it will dereference the location to get this value. So when you dereference, this will be 1004. If you put star of 1004, that is value in 1004, which is 65. You will get this value. So after reading one value, to get the other value, you just need to go to the next location. So you can easily go to the respective location and read the value. This is an array. Suppose if 55 is stored in 1000 and 65 is stored in 2000. After reading 55, if I want to go and read 65, how I can go and read 65? Okay, so after reading 55, the 65 is stored in 2000. Okay, so next to 55, if we can store this 2000, right? Then after reading 55, here you can go read where the next value is. Similarly, here if there is 85, this is in 3000. After reading 65, here also you have to store the next value. In the last value, nothing should be there, right? It is not pointed to anybody. So it can have 0. It can have null. So which means that you just have a pointer which is pointing to the next node. You have one pointer here, extra one pointer you have pointing to the next node. So this kind of data structure is called linked list, because that's a link. It's a list with a link, right? Simple. Now when you have to go for linked list, is basically see here, if you declare, right, you can store only 10 elements, but here you can keep on adding the elements. How many elements you can keep on adding, right? Okay, so how we can implement this in C programming? Okay, so there are two elements in one data structure, one node. This is called node. There are two elements are there. That data can be any number of data also, right? Suppose in the list you have to store student data. So here you will have name, roll number, address, all the things will be there. All the data will be there, plus one pointer variable. That is the next pointer variable will be there. Correct? This next pointer variable will hold the address. For this, how you declare the data structure? Okay, so now let's declare the data structure. So obviously you need to have more than one item in a data structure, so you have to use structure. You can give any name. Let's give the name node. Then you have to declare all the data, right? Name, what's the data type for name? It's a character array, correct? So character, name, 10, okay. Then roll number. Roll number is the integer. Like this you can have lot of data. And finally what you have to have? You need to have one pointer. Where the pointer is pointing to? It is pointing to the same node. The same structure only it is pointing to, correct? The point upon the pointer என்ன type இருக்கணும்? இந்த node என்ன type இருக்குதோ அதே type, same type only it should be there, correct? So the pointer type should be struct node pointer next any name, correct? You should not put an integer pointer here because this pointer is pointing to the same node only. This structure only represents the node, correct? Both the data and the pointer, both the things are there here. So it is pointing to another node. So this is how you have to declare a structure for a single linked list. Okay. So this a structure as a pointer to itself, right? These are called self-referential structures. Self-referential structures, which has a pointer to itself. Okay. This is what is single linked list. It has a single link. Okay. So you can go only forward, correct? In some use cases, some scenarios, this will be little slow to delete a node and all, right? It will be little slow. So you can also have a list like this, right? It will have one next pointer which is pointing to the next node. Okay, this is 1000, this is 2000, and this is 65, right? You also have a previous pointer which is pointing to the previous node. So this is pointing here, this side, this is pointing to the previous node. Similarly here, this is 85, you have 2000 here, which is pointing to the previous node, you have 3000 here, this pointing to the next node. Okay, so this, it has two links, correct? So this data structure is called double linked list. It has double link, correct? So what is the changes you will make in the structure for a double linked list? So the extra variable you need to have is one more pointer which is previous. So struct node star, one more pointer is previous pointer, right? So this is a double linked list, that's it. Okay. Now how to write a code? Suppose you have a function, how to write a code? Suppose I want to, let's assume there is only one data, not all this data, only you have one integer data, which is let's say data itself. Now I am writing a function to insert a node in a single linked list. So insert function I am writing. It is not returning anything, so void, I am passing integer data into A. This function has to insert a node in the list. Okay. So if this is a list, right, you need to have some pointer to the start of the list, correct? Which is called the head pointer. So let's declare the head pointer globally. Struct node star head. I have declared a variable for it. It holds the starting variable. Initially I will assign it to null. Null means I assign it to 0 kind of thing, right? Okay. Now this function is called one value is passed. This value has to be inserted in the list. Now the list is empty, correct? You have not inserted anything. Okay, you have to write code here so that this value what is passed. I will call the function like this. Insert 5 or insert 55. Like this I will call. This 55 has to be inserted in the list. How to write the code here? Okay, so you have the single linked list. You already know that you have one data which is 55. Then it has a pointer to a next node. Correct? So you have a data and a pointer. The pointer is the same node, same type, right? So data can be any data. It can be integer. It can be a collection of data also. Okay, and then you have a next pointer. Right? Now to insert, what I am going to maintain is some global variable. One is head, which will be pointing to the first node. Another one more variable, tail, which will be pointing to the last node. Initially there is no data, right? There is no node in the list. Okay, so both head and tail will be null. Okay. Now we are going to implement this function insert. Okay, so first thing is I have to allocate a node, correct? I have to allocate memory for a node. So struct node, I have to declare a pointer for that first. Okay, I declare a pointer. Smart temp. Now allocate memory. And malloc, what it will do? It will allocate memory and return the pointer. That pointer I am storing it here in this variable. Malloc allocates memory in the RAM and then returns the address where it allocated the memory. To malloc, what is the argument? How many bytes is needed? How many bytes is needed? This structure, what is the size of the structure? Same, that many bytes only needed. You can put that same here, right? Size of struct node. Even if you add something here, the size will change automatically. So you should not hard code here. Here also, it will return a malloc will return a void pointer. You can typecast it. Before the malloc, you can put struct node star. Before here in this place, you can put this. It's returning a pointer, correct? What is a pointer? A simple thing for you to tell. This stores an integer. If you declare like this, it stores address of an integer. இப்போ ஏன்றது எங்க ஸ்டோர் இருக்கும்? இப்போ a equal to 5 அப்படினா அந்த மெமரி லொகேஷன்ல இது 5 is stored. The 5 is stored in the memory location like 1000. The 1000 is stored in a pointer variable. So you can put pointer is equal to address of a. So address of this is a variable a. So address of a means is 1000. The 1000 you can store in a pointer variable. Pointer means stores the address of a variable. That's it. It's so simple. So same way case here. What malloc is returning? It's returning an address. So you have to store in a pointer variable. What type of address is returning? Returning of type struct node. Same pointer you have declared here. Correct? Correct? Now, once you have a structure variable, you can access the field, right? How to access the field? Temp, arrow mark, and what is the field? Data. This data I have to assign it to the what variable is passed. This is a variable. This is the data I am going to store there, right? So this I am storing it. Simple. And what will be the both the things? What will be the next pointer? This is the first node, correct? So the next pointer it will not point anything. So it will be null. Now you have allocated memory and you have stored the data also. Now you have to put it in the list. We don't know whether there is somebody thing is there in the list or not. Okay. So if head pointer is null, which means what? If head is null means no node is there, then only head pointer will be null, right? So now we have allocated. Now we have to update the head pointer, correct? Now the new node will become the head pointer. Correct? Previously there is no node in the list. So the newly now it is empty. You have allocated a node. Right? Now one node is there. And the head and tail both has to point here, right? Head and tail node. because there is no other node. Head will point to the first node, tail will point to the last node. There is only one node. So both head and tail should point to the same node. So first thing, both head and tail will point to temp. Correct? Else means what? Head is not null, which means already one node is there. Correct? So that means what? You have allocated a new node. Correct? Now, in the else case, what is the changes we need to do? So in the second case, one node is already there, you are getting a new node. So in the new node, first you have allocated memory and it is stored in a temporary variable. So this node, let's assume this node memory address is 2000, which is stored in this temp variable. You have assigned the data here and the next pointer is null, this pointer is null. Okay. Now what? So this is the second node, right? So head will not be null, head is pointing to here. Head and tail both are here, is pointing to this node. So it will come to the else case. Now what code you have to write here? You have to change this value to point to this value, correct? This node address, it is there in temp variable. So how to access this value? This node is head and tail. So tail hyphen next will come to this value, correct? So tail hyphen next. Okay, this will what will change this value. You have to change this to point here. This node address is in temp variable. So equal to temp. Correct? Okay, so you have changed this variable. Then temp tail should always point to the last node. So tail you have to move it here, right? So for that, tail equal to temp. Okay, this is tail equal to temp. Is equal to. Okay, finish. That is the thing you have to do. Suppose you are adding one more new node. New node will come. Third node you are adding. What will happen? Come, allocate memory. All the thing filled. Head is not null. Will come here. Tail, now tail is pointing here, correct? So tail hyphen next is this one. This you are changing to temp. So this is updated. Now it is made to point here. Now tail is still here. This tail, temp you are assigning to tail. So tail will come here. So you enter the code to keep on inserting. So like this you can write code to insert write functions to insert a node, delete a node, and you can also write function to display. Right? How to write function to display? Right? Display is basically you have to start from the head node, correct? Head is the start node, correct? Until it is null, you have to display the data. That's it. Basically, right? Display, right? Oh, this is not working properly. In a while loop, you have to from the head node in the while loop, right? You have to keep on printing the data. And then you have to keep on moving to the next node to display the data. Okay.